Okay, welcome. My name is Aishan Rao, and this is the 10th session for programming in Java. And today we are going to work upon Java collections. So, based on the last meeting, I will do the live coding part here, and we will discuss various aspects of uh, Java collection types. This is the first part. Second part I will do in the next session. So, let me start by sharing the screen. I hope I guess you can see my screen. So yeah, please, if possible, can you please unmute yourself? Uh, just a minute, I will unmute the other person. Okay, they have done that. Okay. Uh, so so today we are going to see the collection framework, Java collection. So we will introduce this concept to you, and we will show multiple methods of Java collection as a class as well, and we will introduce the concept of hashing, hash code, functions, and as well as sets. So we will start with this week to get for to set up an overview of Java collection, why it was needed and all. Followed by in the next session we will complete look at all other uh, types of sets of Java collection. We have already seen few in the terms of array list and linked list. So we are not covering that part here. We are covering the rest of the part. Uh, so if you have any question, please you can unmute yourself and you can ask. Otherwise, you can put out in the chat box. I will see that from time to time. Okay, so the first thing is as a collection. So as a basic collection is as a represent a group of objects or group of objects which has certain common functionalities, right? So similarly in Java, what they try to uh, do is they find out certain uh, objects or certain kind of data structures which we can use for manipulation and storing the data. So they have combined few set of such kind of data objects like queues, sets, hash maps, tree set, or tree hash set, like that. So linked list, array list. So these kind of objects they are combined together and they put in the collection framework. Okay, the only difference when it comes for collection frameworks, how they store the content what they're showing in the memory. Otherwise the function which deals with them, like how to add something to it, how to remove it, how to traverse into it, these are some certain common functionality. So how they find a common functionality, they're defining by framework. So it's basically by Oracle Java documentation, basic one. So they're saying that it's a unified architecture representing manipulation and collection of uh, manipulating collections, enabling collection to manipulate independently of implementation details. That means these collections are mostly provided by a certain framework, and we will utilize this framework in the form of interfaces, um, which we use it for our purposes. Okay. Um, so what is a framework comes and what's not. So array is not part of Java collection framework. Okay, so it's not part of the framework, it's a separate entity in itself, comes in util package. Okay, and we will talk about this more in the while we do the coding part. Okay, now how the collection interface look like in general. So in general a collection interface look like this. So it has certain functionalities: add all, clear, contain, contains, or or remove. So if you can see that it usually deals with adding an element, removing an element, passing through them, or check that whether the particular element is present or not. Now using this interface, which is the base interface, you will now utilize it to develop more and more different kind of classes or other interfaces or abstract classes. So these are used for managing a particular group of data, right? uh, so for example, so what kind of interfaces or can we derive is something commonly that we have seen of as of now is list. Okay, which derive this current set of functionalities. On top of it, they will add something more into their elements. Okay, so they add more specific functionalities they want to deal with. So if you say that get add, now they have function of index of, last index of, which is similar to contains, right here, but they are asking for a particular index of that element. They have iterator in the terms of list iterator. Now they have something of set, so also add sorting and sublist also, right? A common element of this kind of interfaces, at least for specifically list interfaces, is they have specific kind of parameter they require, either as an index, that what kind of index are we looking out for, or the element, maybe the element of a list or of any object that we are specifying into, which we have stored in that particular list, right? Or a comparator or an object. So multiple aspects come into picture, but it is not present specifically for collection, but we are extending it further for specific our own purpose, like this in the case of list. Okay, now as a collection of big picture, so if we are going to define it here, is a collection is basically interface. Most of them we're dealing with our interfaces only in this case, which we are using it for our own purpose. So in this, list is one interface, set is one interface, queue is one interface. List we have seen the form of linked list and array list earlier in earlier sessions. Today we will look at set as specifically in that hash set most probably. So every interface has its own implementation. When we say, it's mostly the classes that we're talking about. It has its own set of classes, we can call its own object, we can create this constructor and deal with them. So hash set, link hash set, tree set, all these things are coming from these interfaces. One important aspect is map, also considered like hash map, link hash map, tree map. You might have heard it all already, but these are, though not taking directly from collection, they have their own interface, which we'll look at maybe next session. But it has their own implementation aspect, but it comes into as a part of collection framework. Okay, so even DQ we have deal with that earlier when we are trying to deal with linked list array. So we'll be mostly looking at the sets and map for these next two sessions. Okay, so list, just for recap, we have two type of list: array list, which is contiguous array kind of array list, the array that we are having, and the linked list, that the typical linked list that we look at, doubly linked list, like that. Queue and stack, that is coming from the collection framework. uh, but the new thing that we're going to see today is the set and the mapping. Today is set mostly, so it's basically coming from mathematical set, that it doesn't have any duplicate values, and it has tree implementation: hash set, tree set, and linked hash set. So we will look into this, that how it will work into the picture. Similarly, map as an overview, it has two parts. A map contains a set of key and value pair, where keys has to be unique. It doesn't have duplicate entries, but a value can have duplicate entries as well. But the pair of key and the value should be unique in this case. Okay, now there's something collection class. From here we will start out of our coding part as well. So collection class is not a collection framework, it's just one of the helper class are present, and which will be use it over the period of time to see that how it will and its function, some of the functionality, that how we can use it with other kind of uh, 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 objects or collection framework like list, array list, and all that. Okay, so collection class is something different from a collection framework. Collection framework is as a concept that we have seen right now, which contains multiple aspects, but collection as a class is a helper class. Okay, so rather than looking at it, let's jump to the code and see how we can do it. So I created a I hope you can see my IntelliJ screen. So I have created basically a, project called session 10, and I have a package called dev.eas. In that, I'm dealing with collections as a collection as a class. I have a main function .main.java. Okay, and I already initializes public static void main. Okay, so let's do few things here, and then let's start it off by discussing about collection class. Okay, so we are going to talk about collection as a class, few of the things. Um, so let's create a string first. So I'm creating a list of type string, naming as list, and I'm keeping it as new array list. Okay, standard this thing. Now I will create uh, array of strings which I'm passing few values. So I'm passing few values. So okay, now once I have these values, how I can add it in the list? Using the function called add all. So I will take add all, and since a list wants a list as a input, so we can convert an array into as a list using arrays.asList. Okay, so since I'm using IntelliJ, I don't need to add any of this import statement. It is automatically added as I'm writing invoking their functions. And here I will pass on the string array. So once I'm adding this, the list will contain all this value, and if I just print it out, so let's say system.out.println and list. If I just print it out this, um, let me run this code. So it's a simple basic list, and we are in that list we are adding a few string, a few names stored in string array, and using add all function we are adding this out, right? So building will take some time in my case, in my system usually. So let's see, it will print out the same names that we have seen here in the line number 11. It will print out the same names. So apart from this, now let's do something else while it's building, while it's parsing also. uh, okay, now parsing is happening. I should not do anything. Yeah, now I think it will, I can write some things. Okay, so this is how the output will generally look like. And this is basically a list how you can look like, right? Now what we'll do is I will comment out this uh, thing, and I'll copy this. Now instead of specifying exactly list, I can use collection. Collection is list, and I will just say it like this. So if the moment I keep as collection as a word here instead of list, it will automatically identify that this collection is linking to this list, class list, and from this I can create an array list. So if you can see that there is no red line, IntelliJ is saying that this is perfectly fine. And if I do this, if I hover on list also, maybe here, so it's tell that it is working pretty much fine. So if I run this code also, where instead of directly turning list, I am using a collection. Why? Because um, as we have seen earlier, as a collection interface, collection is the interface, so it now list interface has inherited this. So because of the polymorphism, because of inheritance, I can directly use the collection word here, that instead of directly invoking the list, and I can use this. Okay, similarly if I try to, it will give me the same output, but let's say if I, instead of collection, I would want to have some tree set, so I can do string. So it will, yeah, it will give me the same output, right? So I want to observe that the name as it is, whatever printed, it's adding up like that. Now what only change I'm going to do here is, instead of array list, let's add something new which we haven't tried out, that is like tree set. Okay, the tree set is also coming from the collection framework, and if I run this in this case,
Excuse me, sir.
yes.
The collection, you say it is an interface, and can we create an object of that?
No,
Not implementation.
we can't create an object of that as of now, because
Now,
it's
when you say new preset, what is happening, sir? When you say new preset,
when you say new tree set, okay, it is creating a object of tree set only, but it's a
No, what
reference.
is preset? Is it a class?
Yeah, it's a class. It's like same as array list. So let me show you. I hope you can see a list here, a collection, this slide. Okay, this it contains a collections interface. Now it has more interface list, and its implementation is linked list, array list. Similarly, tree set is an implementation, which is a which is a class from which you can create an object of a tree set implementation, which is accessed using sorted set, and whose parent interface is actually collection in this case. So as you have seen in polymorphism also, right, or in inheritance also, you when you're trying to create an object of a subclass, you can have the name of its parent class also. The same concept, we are adding it here also. Yes. Um, Now if we do this tree set again, run this, it is giving me the same output. Okay. uh, One more, just for sake of completion, we have seen here tree set. Now look at the hash set here, and then we will move ahead for few more functionalities. So I will just keep it, and I will hash it here, and I will just run this. So for the point here is I can create a list, or any a set. In this case, we are actually creating a set, not a list. Name, even the variable name has list. Java cannot find. Okay, let me run this again. Okay, now I want you to observe the output first. Now it has the aspect of hash set, not the tree set. Now when you use hash set, what is happening here is the output is coming randomly. Even though I put some Anna, Bob, Carol, David, Edna in a particular order in a uh, name list, but here what is happening here is it is coming as an unordered set. Okay. uh, Sorry if you're getting some noise, it's coming from the outside in the background. Okay, so why it is like that? Because it is implementing a set, and set basic quality is I can have any element which is not duplicate, but it will be stored in an unordered way. Okay, so hash set and link set are we coming from that part of view, but when you go for the sorted set, tree set will sort it according to its particular value. In this case, the capital, based on their names, it is sorting it. But if you use hash set, the output will be coming in an unordered way. Okay, so that's a difference between tree set and hash set. Even though it's coming from the same interfaces of set, implementation wise it is sorted versus unsorted. Okay. uh, Another thing, now this is there, let's add few more stuff. So let's say I will add few more names. So using add function I can add it on, and let me add few more. uh, so let's say using dot arrays dot as list, and I will add few more names with the same in starting letter. So and then let me print it out, the original list. Also what we will do here is something different. uh, we will try to find Gary in this name. Okay, So how we can find it? We can using the contain function. So Gary in the list dot contains. Yeah. So if I try to run this code, I have some list which is a part of hash set. Okay. I can add it. I can add all as a function, and I can use a list dot contains one. Okay, so it is all coming from the function that I have used right now. It's coming from the collection framework itself. So, so just to show you the difference. So we have used till now, we are all using the function directly from the collection interface itself. So we have used these three functions as of now, and we can use, since collection, it's a super interface for the hash set that we are using here, we can exactly access it. And if I just run the code, okay, I'm having the values. I've added this four names, so it has been added, but since uh, it's a hash set, so it come in an unordered way. And also, because of contain function, we can find, and it will return the boolean value true or false. So it is providing us the true or false value. All this is fine. So let's look at the few more things. So let's say in this, if we want to have a remove function, if we just want to remove, okay, so it is asking for a particular rep predicate or particular kind of condition here. So if we want to do that, let's do it. So list dot remove, remove if, and I'm going to write one predicate here, s dot caret, and equal to g. So it will remove any name starting from g. Remove any name starting from g. Okay, that's one thing. And if I just print it out, so what I will do, instead of doing this, I will just copy paste these two. Since I'm removing any name, so it should give me some different result in this case. And if I just run this code, so our output is the last two lines. In this you can see that the list that we have, the hash set basically that we have just removed the g, any name starting from g, and it's checking that whether the particular name Gary is list or not. So it is providing us false value. All this code, okay. So in this code we have seen that we have taken the collection framework and we have used some functionality called add all, contains, remove if. Even though if I just remove any of these, and if I can add test set, tree set, or array list also, it will work perfectly fine. So I will show you that also. But before that, let's talk something else. This predicate, that one, uh, we have write it down. So just let me copy this. So can anyone tell me what is this predicate tells about? It's a particular type of expression. Does anyone know what kind of expression it is? Why it will work? Why it is working out specifically in this case? I'm the one I'm highlighting right now. Any idea? You can unmute yourself and you can speak. Otherwise, you can type in chat box also. Okay. So this is basically called as lambda expressions. Okay, so lambda expression are small sort of smallest functions that you can look at into, smallest expressions that you can find. It's called anonymous functions, small functions like that, which returns me a value and I'm also providing a I'm also passing a parameter, given a parameter. So if I want to show you this part, let's look at lambda expressions here. Okay, so it is added in Java 8. So it is the simplest lambda expression contains like this parameter, uh, and then with arrow and expression. So that means given a parameter and the expression where it will calculate the expression, it will return me a value. Okay, it's a short block of code which take parameters and returns a value. Okay, it's basically a method, but here we are not defining any body specifically to it, and anywhere we don't need a name for it, and it will directly calculate it. Okay, so this is a new concept that is present in the Java from Java 8. In other languages present from long time, but in Java it has had been added recently from Java 8. Okay, so for example, uh, let's say you have an array list and you're adding some number using add function. Now if you want to print it out, so what we usually do is we will write a for loop, and we have to write 2-3 lines of code, and we have to pass on I value and the size of that value and then print it out, right? But for each function of lambda, what it will do is it will pass the parameter as n. The list that we're passing here is numbers, which is array list. So for each number, uh, for every element of number which we're naming as n, it will print out system.out.println. So it is similar to for loop, but we can write everything in a single line of code. Okay, so this is the lambda expression. I'm not going deep into that because I haven't checked whether it's present taught in that class also or not, but this is something that you should try it out in yourself. So same thing we have done here. So in this case, list r is the main object in which we are traversing, or main data in which we are traversing, and s is the parameter, and is our expression. Okay, so this all constitute that if I get so if this expression returns me true for each element, it will check that first character, and if it is G, it will present true, and if it is present true, then that list will remove that particular element out of this. So that's how it is working it out. Okay, so that's one thing about lambda expression. Another thing is, now it has work on hash set. I can comment it out and I can put reset also. It will work pretty much fine. So if I just run main again, all this function will work. It will work for array list also, tree set also, hash set also, because everything has been derived from this collection interface. So that is what I just want to highlight in this part of the code. Okay, so output wise it is coming same. Only difference here is the way output has been presented. The list has set was unordered, reset is ordered one, array list also ordered one. So the way we have passed on the values, the same way the values will be stored. So only difference is that, but remaining wise, the lambda expression output, or the whether the particular name is present on that list or not, that output will be same as earlier. Okay, so this is the collection class. This is the overview of class. Now using this, we will see more more different type of collection methods. Okay, so for that, let me create a new function, new library, new package. So let me create, just a minute. Collection method, and I will create main2.java, and I will create a record called card. Okay, so what we will do is, first let me create a code setup for this, that is in this case card. So what we'll do is we create a our aim here is to create a deck of 52 cards, okay, which contains 4 different types, that is clubs, spades, hearts, and what else we have in the cards here is diamond. Okay, so we'll create this all the 13 different types of cards. For each of these types, 13 different cards, and we'll create a for all these types such that we can get a 50 set of cards. And once we create this, then we will start looking at how we can use collection, different kind of collection methods here. Okay, so to do that, I have created a record. The why record specifically, the reason is simple here, because I once the record has been created, it is fixated. I can't change any of these in between value. I can create a functionalities of that, but once the object has been created, I can't change it any value of that. So that is why it is preferred over creating any object, because our object of a record is considered as a static, and it's considered as final with respect to it. So that's why we are using it. Otherwise, if you want to use class also, that is fine, but we have to look at some different aspects into that. So I'm creating a record, so let's do that, and then based on that we will see the other aspect. So there's something of suit, I will come that to that. So for a card, we are defining 3 aspects. A card contains 3 aspects, that is suit, its face, and its rank. Okay, so suit in this case any of the 4 types. Suit suit can contains any of these 4 types. Okay, face will be that is 2 to 10, or uh, joker, uh, queen, king, or ace, like that. And rank is the position, like it's from 0 to 12. Okay, which is the lowest card, which is the highest rank card. So that is what we are trying to set up here for a particular given card. And in this, I am putting public enum for suit. So in this, I am defining club, diamond, heart, spade. Okay, so these 4 values we will looking into. And also what we want is, we want its actual uh, image of it when we are trying to call it, right? So we can do it using get image. So this is the current code setup that we are trying to do, based on which we will use all the collection functionalities. Now once we do this, now return new char. So I have the values of the how the club look like, how this kind of ASCII values that we are looking into. So let me write it down. 29. So these are ASCII values for all these values that we're looking, and we are trying to link each of these ASCII values with these 4 using this dot ordinal. Okay, so what this function will do is, whenever we are calling this particular enum suit and we are specifying any of these values, let's say suit.club. So while returning using the get image function, we will find for club 9827 as ASCII value will be passed. Okay, diamond, it will pass this value. So this values we are passing out such that we can use it while printing out a particular deck. So these are the only for suit, and you can consider it like a inner, uh, not like exactly a class, but consider as an inner class only, because it's a part of a record in this case. Okay, it's not exactly in a class, but you can consider like that, that we have a certain values and certain methods within the class. Okay, now I will add toString function. So for that I will override it. So using toString, that is how we're going to print it out. So in this case what we're trying to do is we have to print out each card value, right? So that's where the toString is present, how we can print it out. So for this int index, first we are identifying the values. So index wise, so if face, what is the face value, the value of the card? If it is 10, so index can be 2 or it is 1. Okay, so from 2 to 0, sorry, 2 to 9, we can have index value as 1. Only for 10 the value can be 2. That's why the position 2 is given here. Okay, that is for our understanding. Then followed by string, face dot substring, and 0 and index. So when we are looking at the index, we will look at that how many number of substring we have to extract from the face, and then when we are returning it out, we are passing certain values. So let me do that. So we are passing face string, suit dot get image, and rank. Okay, so what here we are trying to do is we are trying to, for each card we are returning this return value that is consist of face string. Okay, that is 0 1 2 3 4 like that, or jkqa, that part we are trying to do. Suit dot get image, so whatever the get image value we are trying to value is, that ASCII value we're trying to get it there, and from that we'll print it out, and the rank of that particular card that we're trying to print it out for each and every card that is present in a particular deck. Okay, now we're going to do two more things, two more function first. So let's write it down. So we have to deal, now we have two types of card, that is uh, cards, that is numeric, that contains of 2 to 10 values, and face cards, which contains four values, that is joker, queen, king, and ace, right? So for that we are writing the specific functionality. So we're keeping the public static because we have to access it. So get given a face card. Okay, we are calling for suit, which of these face card is, and char abbrev, and what its abbreviation, that is JQKA, like that. Okay, so first we are checking char index JQQA, any of these word present in the um index of abbrev. So we'll check any of the index present in this char. So whatever is that, we are trying to check it, check off with this. If whatever the index is, we will return it out. Otherwise we will see that if char index is greater than -1, so it will pass on either true value or the -1. If it doesn't match, and any of the abbreviation that we are passing here, if it doesn't match with any of these four letters, we'll pass the -1. Okay, so we are just checking for that. If it is not -1, then we are creating a new card. We are telling the suit um, the abbreviation of that card name and the car index +9. So we are returning its rank also. So what does it means is, um, so the card with 2 is the lowest rank of 0, but joker has the rank of 9. Okay, so char index, if it is joker, joker value is 0 in this case, so 0 plus 9, the position is 9. K value has 10, sorry, Q is 10, K is 11, and A is 12. A is A's, right? So any of the index that is 0th or Q 10 and all, we are just adding 9 into it. Okay, so if this is there, we will return a new card. um, Otherwise we will say invalid, sorry, face card selected, and we just return null value. Okay, so it asks for a card. When we're creating a face card, it is asking for card, so we're returning that card. Okay, similarly, we'll copy this, and I think we can't copy this, so I will create a new for numeric card as well. So public static card, and get numeric card. In this, we're passing the same thing, suit, and in this case, instead of character, we'll pass the number, card number, that is 2 to 10. Card number, we are passing it down, and if card number is greater than 1, that is 2, in this case minimum has to be 2, and card number has to be less than 11. So if these two conditions are satisfied, then we just return new card suit string dot value of card number and card number minus 2. Okay, so let's look at it. So it will call for a particular suit in this case, uh, and this suit will contains the card contains the value of card number, that is 2 in this case, or 3 case like that, and its rank. So as I said earlier, the rank of 2 is the lowest, then followed by next lowest rank is 3, which is rank is 1, like that. So that card number we are asking for here, and if it doesn't work, um, so it will work if the card value is between 2 to 10, and if it doesn't work, so we will just write it as invalid numeric card selected and return null. Okay, so these two cards have been done. Now what we have to do is we have to create a standard deck and we have to print it there. Okay, so now we know that using these two functions we'll create the standard deck and new deck. So how can we do that? So public static list. Now since deck is a list of cards, so we expecting that output should be a list of cards only. So for that, get standard deck, and we are not passing any parameter in this case. So list card, the list will be of type card in this case, and the card that we are talking about is this, the record. Okay, so that we are talking about. So in this case, card, the name of that list will be deck, and new array list, and since a standard deck is of size of 52, so we are keeping like that. Now we are what we do, creating each card one by one. So we are passing to the suit the enum values, suit dot values. So for int I equal to 2, I is less than 10, equal to 10. So we are first creating the numeric cards, I plus plus deck dot add get numeric card, the particular suit, and I. Okay, let me write the full code and then I will explain what actually happening here. Similarly, char c new character array, so it will take the characters from this character array, in this case J, Q, K, and A, and deck dot add that add function that we take, get face card suit and C. Okay, so once you do this, we just return it out, return the deck card, the standard deck. Okay, so what happening here is, so for each suit, in this case the suit is whether it's a club, for club, diamond, heart or spade. First I will, for the club I will go, for the club suit I will create 2 to 10 numeric cards. Okay, then for character and for creating a face card I will create this 4 face card. Okay, that is for one suit. Similarly for other suits also we will do like this. uh, Now if we just to complete it, since we have created this, now I have to print it out also. So let me write out print deck also. So public static void print deck. Okay, so it contains the list of deck that we are asking, that is list of card, description if any provided, and rows. So let me just do some. Okay, so if there's no description, no, so if this description is not equal to null, system dot out description. And now what we have to do is we have to print the card in particular rows. So what we will do is we will depend on the number of suits that we are having. So cards in row is equal to deck dot size and rows. Okay, so whatever the size will be, in this case we are creating a deck of 52 followed by rows. The rows here we are specifying mostly 4 it will be there, but we can specify it explicitly also. Now so to print it out, we'll take a simple for loop and we are printing row wise, and in that row first we are looking at the start index and end index. Start index plus cards in row. Now what we'll do is since it's a list, we will take its sublist from it, and based on the start index and end index, now we are using a lambda expression here, that is for each row system.out print C and plus give some space, and after every print of the row we just print a new line. Okay, so what's happening here is given the number of rows how we want to print our deck, we will divide that rows, and then from that we will try to find the start and end index. Using that end index, using the sublist function of the list, since our list by default our deck is this list, array list, so using that we'll extract using start and index that particular number of element, and that from that element we are writing another loop which is coming the lambda expression, where for that particular sublist we are printing each and every element using system.out.print, and after every row we are printing a new line. Okay, so in this case just let me write one more public overloaded function. So let's say if I don't provide description, I still want to print deck. So how can I do that? So print deck, if I just pass the deck only, that the list of deck card only, so I will just call this function print deck and deck. I will provide the description of current deck, and the rows is default. So by default, if I just call print deck with the deck I'm passing, by default it will call this function and it will call the particular next overloaded function with particular print with the particular description. So only thing that I have to do here is, now once my whole card setup is done, um, so here so let me just give the output and then maybe we can understand it much better what we have done here. So let me write get list of cards deck and using card dot get standard deck and card dot print deck. If I run this code, okay, so it will give the output something like this, where we have created a standard deck of 52 cards. Now each row consists of one type of suit, in this case club, then diamond, then heart, and then this should also be actually spade. That means I've done something wrong in the card. Okay, I've written the wrong name number, so in this case 9824. Okay, so if I just rerun this, but you got the gist here. This is standard deck of card where we are passing the name of the card, that is assigning the value, that is face value, in this case 234, followed by J Q K A, and followed by, in the brackets we are assigning the rank of that card starting from 0, that is for face value of 2, and 12 for the face value of A. Okay, so this is a spade. So this is how our current deck look like, and for that what we have done here is, in card.java we have defined each and every suit, and for each suit we have created two type of cards. So first card that we try to create here is get numeric card. So that numeric card will create from 2 to 10. So this is the card set it will create using get numeric card function that we have defined, in this case from line number 39 to 46. Okay, uh, now for the remaining face card values, that is JQA, we are defining deck.add get face card in this case. Okay, so this first face card we are defined here. We are checking for the initials what kind of card face value we're creating, and from that we are creating a new card. Now based on this we are storing all this particular set of we are doing it 4 times for each suit, that is in this case club, diamonds, heart, and spade, right? So we're creating 13 cards, and main thing is it's all a list. We are just printing out it as a 4 rows. So if I just create, instead of 4, if I do 8 rows also, it will work. Okay, so eventually all this thing, that current deck you can see is basically a list, array list in this case, and here we are defining 3 values: the numeric value, its character, ASCII character, as well as its rank. So these 3 values we are storing as a array list, and that's how we are printing it out. How we are printing it out? We are printing out using print deck array, print deck class, method. So we based on rows, number of rows that we're defining here, we're dividing the deck size into the number of rows. So we're defining the number of cards should be present in that row, and in that we are finding the start index and end index, and from that deck, since it's an array list, from that we are creating extracting sub list, and we are printing it out. Okay, so each row we are printing that sub list. So that's how it is working it out. Okay, so this is the main setup of card deck. Now what we will do is, on this card deck, what we will do all type of different functionalities provided us by the collection frameworks. Okay, so that we will do. So it's almost 1 hour. So we will take up maybe 5 minutes break, and after that we'll come and we will try to now give, this is the data that we have, this is the data that we have created. Now how we can manipulate it in multiple different ways, that is what we are going to see in the next part of the session. Okay, if you have any question with this part of the code, please let me know that it is going overhead, or is it something it's understandable to you part, or anything else that with respect to this, please let me know in the chat box, or you can unmute yourself as well. Okay, so what we'll do is it's 6:57, I guess. um, yeah, it's 6:57, so let's come back at 7:03, I think. We'll come back, and from there, given a deck, we will try to manipulate it using multiple collection functions, how we can do that. Okay, so we will do that part. uh, yeah, so 7:05, so we will, I just put down in chat box also. Say 7:03 p.m. we'll come back. If you have any doubt, please put down chat box, um, and or later also you can ask me. Okay. Okay, welcome back. Uh, so I hope you're getting the following this session, this part. What we are going, so what we have done till now is we are looking at the collection aspect, and we have done a setup code as of now. So the setup code is that we had made a deck of cards of 52 cards of 4 different suits. Okay, so now what we'll do is now we got this data ready. Now we will try now we will use the current collection methods, which we can use it in this there are um, uh, multiple functions are there, so we'll use some of them, maybe 10-15 methods. We will look into this to see that how we can use them to manipulate it. Okay, one more thing I forgot to share is today's code. Let me share that part as well. Okay, today's code has been shared. um, Okay, so let's get back to the code. And so we have created standard deck, and it's printing out pretty much fine. Everything is working fine. Okay, awesome. Now what we'll try to do here is um, let's try to see that what other things we can do with respect to this standard deck. So what we can do here is instead of creating standard deck all the time, can I do something else with respect to it? So let me try to create an array first. So let's say card. I'll create an array of cards, and I will try to get a particular type of cards only, particular suits of cards only, so which I will try to store that in a particular array. So for that I'm defining the card array as 13 size. Now how can I get it? So uh, card, ace of cards. So I will try to get only particular type of card only. So let's say ace of hearts, and I can create it using get face card and card dot suit dot heart, and I will abbreviate A because I want only ace, so I will use that, and this. Okay, so what now, to understand that how we get to this part, card dot suit dot heart, we have to understand that this is a record. If I hover it, it's a record, public record called card. That public suit is a public enum which comes under card. So since we have returned this enum class, which is inside a card considered as an inner class, that's why we have to access it directly using card.suit. We can't create an object of it. Then since it's an enum, we can directly access its value here. So that's why it's heart. Abbreviation A, that means we are saying that we want to create a ace of heart in this case. Okay, suit heart, and the face card is A, ace. Now using dot arrays dot fill, I'll try to create card array, and ace of hearts. I will fill the array with this, each 13 element try to fill, and then I will print it out, card dot print deck arrays as list. Since one of the parameters is we are passing for print deck is list, so we have to pass it out as a list only, and we pass this character array, say card array, as a list there. We're telling the description, so ace of hearts, and the number of rows that we want it out. Okay, so if I run this code now, so we created a card array, and we created a particular card also of ace of heart, and using that particular card we are filling the whole array. Okay, that now we're trying to print it out. So the output will look like this, that this is a basically a deck which we initially was a card array okay, which we convert as a list, and followed that we are printing it out. So everything is normal. This is working pretty much fine here. So using the fill function, we are given a same word or same card, we can copy it and then we can do it. Okay, we can fill the array with the same values, right? So that is the array.fill function come into picture. So this is the fill function that we are talking about. Now let's try to do with the collection part. This is the array.fills, right? Let's do with the collection part. So let me try to do here. um, Let me create a list of type cards, name it as cards, and it's a new array list. And capacity, initial capacity we're giving it's 52 because that's how the size of deck is. Now what we're trying to do is collection dot fill cards and ace of hearts, and then we'll just print it out this list. And its size also. Cars dot size. Okay, so if I run this, so what I'm doing here is we have created a list called cards, okay, kind of standard deck. Now using fill function from the collections, we're trying to fill the cards with this ace of hearts. We're using one card, we're trying to fill all the 52 cards place. Okay, that's we're trying to see. So we want to compare the array.fill and the collection.fill functions and see that how it will work out. So if you just run this, so we just want to see the comparison between arrays.fill versus collections.fill. Okay, so the first output ace of card coming from the arrays, it is working pretty much fine. But what something is happening is the array.fill function is not working it out here. Okay, and it is size is also 0. That means the ace of card that we are taking, which is of type of card only, it's not completely it's not able to work with this function also. So that is something we need to check why. So what we can do is control plus, I guess, uh, I think I can extract it. Okay, okay, I think I need to check how can I extract it, but based on its definition, the way a particular card has been taken and added in the card array, it's not the same way it's working here. So what we have to do is the fill, it doesn't copy its list of ace of heart and adding in one of each of these elements. Okay, so that's not able to done by the dot fill file. It is work mostly for arrays, uh, but it will not work for as a collection dot fill. So what we can do in this case, what we can do is we can use something called as ncopies. So ncopies is a function to replace fill in this case. Okay, so uh, so we can the same thing we can do list of card, and I can write ace of hearts and collection dot ncopies, and we can type the number of 13 and the what we want as a copy of ace of heart. Okay, uh, I think what I should do here is I should do ace of heart here. Now it will work fine, and I will just print card dot print deck. print deck and ace of hearts, and number of rows is 1. Okay, so right now what we've seen is in collection.fill, uh, the collection.fill is unable to copy the ace of cards here. Okay, so that's why as an alternative we are bringing n copies. So if I just run this one more time, so let's see how it will work it out. Okay, so even the fill is not able to copy the particular card and put it place in all the relevant position, the end copies can do it easily, specifying the number of places that we want to put it out and then specific card which we want to put it out. So it will take each copy of it, that is it one copy, each copy of card it will take and copy it on all the 13 places. So that's how it is able to do it here. Okay, so this is working out. Maybe we can do it for one more, that is maybe king of clubs. So what I can do here is um, I can create another card. So let me show you for another card also, and I will just add this part also here. Um, so card will be in this case king of clubs, and I will take get cards. So I will just take clubs here, and abbreviation will be K. So list of cards, and I'll just copy this part, king of clubs, and okay, so if we run this the same thing will happen. So I just write it down, king of clubs. Okay, so similarly if I run this code it will also create a deck of cards which consist of 13 king of clubs. Okay, now this is fine. So n copies works, so we can see that n copies is basically try to overcome the fill part. It creates copies of an element, okay, and paste it wherever it is necessary. Okay, now let's try to do some more things. So what if uh, we try to add multiple cards together? Okay, so let's say I will add cards dot all. Now why cards? So because my cards is basically a list of cards. Okay, now if I have a list of cards, now if I do add all, and I will add here card array, and I'll just do card dot print deck. I will just do card collection with aces added and with one row. Okay, so if I try to do this where given a list, I'm trying to add the card array. Now it's showing me a red line in this case. So what does it mean here is some error. So they're asking that I should have a collection only. I can't provide a array of cards. Okay, so it will not work out. That's what it's saying. So how can I add it? To add it, what I can do is I will take a help of collections again. So collection dot add all. I will keep cards and card array, and if I just run this code, there's no error from the IntelliJ as of now. So if I just run this code, Okay, so this is the final thing. Since now you can see that cards initially was empty. These are cards, this one. So we created a list of cards of as an array list which is size 52. Okay, even though filled it with ace of we haven't filled it using collection.fill, it's not filled, so it is empty only. Okay, so in that empty we added the card array, and because of add all it's able to handle the both different part of it. But if I just try to uncomment it and try to as a list, if I'm trying to add a character an array of cards of different type, it is giving me an error. It is asking for particular collection. Okay, so it will give me an error for this. Another method to do this part is I can do collection.copy. So I can what I do collection.copy, and what I can do cards dot king of clubs. Okay, and I will just print it out. So let me take this. I will just say above card collection with kings copied. Okay, and if I just run this code, so what I have done is given this addition of new cards, I'm adding, instead of using add all, I will just use copy function directly. So this is another function that we are looking into apart from this, and copies and add all kings of club. So let's see the output. Okay, now what is happening here is it is copy is overwriting the existing words. Okay, it's not concatenating it, it's overriding it. So the aces that we have seen here in this above line that is printed because of line number 33 of the code, it has been overwritten by collection.copies. Okay, so that is one thing that you have to keep in mind, that it copy function usually overrides this. So how to solve it? So if we can do it, can we do something about it? So let's try to see what are the things that we can do. So for this, let me comment few parts of the code here. Okay, what I can do is collection dot cards. Okay, now another thing we can try it out here is, okay, so if I do this, so I'm adding now, instead of, since copy is overriding, right? So let's try to see if I using add all function itself, can I add it? So using card of array only, I'm trying to add two rows. So since I'm adding 26 cards in this case, I will get two rows. So let's see what will happen. And I will just comment this part and just let me run this code. So add all will help us to concatenate the values uh, in this case, and then using which you can play with it. So the output we will see. So in this case, since add all, it will concatenate the value, it will not overwrite it. Okay, so you can use add all function, but if I use that part of also, that is collection.copy, and I'll just change it to no row number 2. Okay, so given a 26 number of cards, what we're saying, we are using copy. So we have seen that copy can overwrite it. So but we have to see that whether it will overwrite all the 26 values or not. Okay, so that is we will see now from this output. So as you can see that it can't overwrite every single thing. It can overwrite only the values till which it is present. So in this case, 13 cards we have with King's Club. So it is can overwrite only for that. but for the remaining it will remain as it is. Okay, so that is something you have to remind of, that when you're using copy function, it can't overwrite every single thing. It can overwrite only till the part of values where it is needed of. Okay, then another way where using which you can try it out is uh, cards dot uh, list dot copy of function, which is directly present from this. And if I just do kings of club, I think something is wrong. Why this is, oh, kings of club, sorry. So okay, if I just create a list of copy of and put it into cards in this case, and I will just uh, print card dot print deck cards list copy of kings. Okay, so if I do this, and that means instead of collection dot copy, I will using the list function copy of function directly. So if I run this, it will give me the copy it out, but only thing is it will give me an unmodified list. Okay, so uh, now later if I try to do something to this kind of list, I might not able to. This is give me unmodified list. Okay, so that is one thing that we have to keep understanding as that aspect of. Okay, uh, so it will give me the copy list. So what we have seen till now is so for a copying a value, we have seen add all function and copies function, copy function, and copy of function. So four functions from the collection and the arrays and list that we have seen that we can use uh, to copy a particular element from one list to another list, or one array to another list, like that. Okay, now let's go beyond this and try to deal with the deck itself. So what we'll do right now is look at the other type, that is called as shuffle. So this is called shuffle function, that given a list you can shuffle all the elements together. So how we can do that? So let's create one list, basically a deck of cards. So I will just name as deck and card called get standard deck. Okay, and card dot print deck, and collection dot shuffle, and again I try to print it out this part. Okay, so shuffle is not okay, something is wrong. Okay, I have to pass on the what the value. Okay, okay, so let me run this code also. So what shuffle will try to do is, given a card, it will randomly try to shuffle the all the deck into in a random order. So let's see how the output will look like. Actually, I should have done here some more description. Shuffle deck and pass on different rows. Okay, let me see the output. Yeah, so this is the original deck that has been created, order 1 from 0 to from card 2 to ace card. Now because of shuffle, collection dot shuffle, you can see that it has been shuffled in a very random way. It has been done automatically. So that is something you can do it. How it does it, we have to check the shuffle function present in the in their what you say in the documentation, but as of now it randomly shuffle all the elements from one part to another part. So that is one thing. Another thing what we can do here is not in a shuffle, we can also reverse it. So So let's say reverse, and you can just use collection dot reverse, and you can just write out reversed deck of cards. Okay, now since we might not able to understand the shuffle part, so I will just comment it out for now, such that we can know that it is properly reversing the deck of cards. So yeah, if you have any question, please let me know in the chat box. Okay, so this was the current deck that we are having, which we have created. Now for reversing it, so for each row it is doing it each row wise, not even row wise, it is a whole deck only. So as you can see that the club of ace is basically the first element, and the so spade of ace, and the club of 2 is the last element here. So using collection dot reverse also you can do these kind of operations. Now apart from this, we can also sort it. Okay, so for sort, as we have seen discussed earlier, that we have to do some kind of comparator, some kind of algorithm. We have to tell that how do we have to sort it. So for that, let me just first create a sorting algorithm that we can use using comparator interface. So we are using comparator dot comparing. So how we are defining it is like we are first compare it the card with respect to rank, and then compare it with respect to its suit. Okay, now this algorithm is there. So using comparator interface and its comparing function, we're specifying that a card should be first sorted based on its rank and followed by its suit. Okay, the suit in this case is so it will first consider club as the first one, followed by diamond, followed by heart, followed by spade. Okay, so once do this, we will call collection dot sort and deck dot sorting algorithm. So we are telling that how you should sort that particular this thing, and uh, and then we just print it out. So card dot print deck standard deck sorted by rank suit, and this mm, let's say let's change the number of rows from uh, 4 to 30, and let's run this code. Okay, so when we are sorting it, so we divide by 13, but you can see that how it is happening. So it is first sorted based on the rank. So all the 0th rank will come into the single lane, and it's because we have defined the then followed by suit. Since all of them same rank, we ask them to follow by suit. So club, diamond, heart and spade. So it is coming from the way how we are defining it here. So if we change its or enum order, this part will also change. Okay, so that is the sorting algorithm that we are trying to define here. So it always we have to tell about that how we have to sort it. Okay, so we can't just write deck here and it will work it out. We have to tell the sorting algorithm also. So that is what we have written in this case using the comparator interface. Okay, so that is for sorting. Now in this also you can try to reverse it. So what we can do is just copy this above line. Now we can just reverse the deck. So I just write here sorted by rank and suit reserved, and if I just print this out, Okay, so this is how exactly it has been reserved, uh, based on this rank and the suit. So all this thing is fine. So so what we have seen till now is, given a deck, we can shuffle it randomly, we can reverse it, we can sort it given a sorting algorithm, right? Now, but if you want to, given a data, you want to specifically take on specific sublist of that, how can we do it? So here we will use the function called sublist till now. Okay, so to just to revise what we have seen till now, in this case we have seen earlier add all function and copies, copy and copy of function from the collection classes. Then till now we have seen shuffle, sort, followed by reverse. So these three functions that we have seen till now. Now, we are going to look at, given a deck, if we have to do with, we have to deal with only sub part of it, how we can use, we will use the function called sublist that we have already seen in the list part also. But we will see that how it will work in this case also. So let's say list card. I want to extract only specific kings only. So what I can do is new array list. In the array list I can say that sublist, since I have already reversed it, so 4 dot, so I know the array, that A is followed by king, so I know the its position, so I'm passing this index here and I'm just printing it out. Card.printx and kings in deck. So if I have to extract it, a particular sublist, not only a particular element but a list, I can just write like this. So I should know the obviously I should know the index of that particular sublist also. So if I just run this, okay, I think I have done something wrong here. Let me check. I should give sublist 4 to 8 only, and it is king. Oh, I should pass kings only. Okay, my bad, I have done wrong. Let me run this again. Instead of kings, that is the new sublist that we have extracted, I am just passed the whole deck itself. That's why it gave me the wrong answer. So let me run this again. Okay, so it's, we know that after reverse it is in position 4 to 10, that is 0 1 2 3 4 to 8. So that is what we are able to extract it. Similarly, if I want to extract some other part, so let's say in this case tens, if I have to extract tens, so I should know that's list, so it is at fifth line, so it is maybe from 16th to 28th. Okay, so I need, it will include the 16th position, but it will not include 20th. It will be 1 minus n minus 1, that is 16 to 19th. It will take that, and it will take tens in deck, and if I just pass it out 10, it will similarly print it out how it is printing here. Okay, so that's how we can extract the sub list. But there's something else we can do here. So let's say uh, let's say if you want to extract this index of particular sublist. Okay, so how we can do it, if we don't know this particular number, whether we can extract something out of it, how we can do that. So for this, um, there's a function, so let's look at that. So int sublist index, and what we're doing is collection dot index of sublist. Okay, so I will pass the deck, and I will pass the that particular sublist which I have. So if I want to know what is the starting position of that, I can do that. I can store that value, integer value, in sublist, okay, using index of sublist, and then system.out.println sublist index for tens, sublist index, okay, that is we can do. And also we can check whether all the all the elements on the sublist present in the deck or not. So if I just do system dot out dot println contains deck dot contains all function, okay, and just pass the sublist that I have. Okay, so first thing it will try to understand, try to give me the list, index list of that particular sublist that I'm trying to extract, and also check whether all the it contains all the list particular element in that or not. So if I just run this code, yeah, so we are looking at tens of deck, that is this that we extracted. Now sublist, that is from where the sublist has been started, we are extracting it, and its position is at number 16th, that is what it there. And then if it is contain all the elements of the sublist, so it will say that it is true, okay. uh, Now follow which, if I do something else, then let's say I shuffle the deck, collection dot shuffle. Now after that also, can I get the same output or not? Let's see. So till now it is ordered and sorted, so we can extract it. Now we shuffle the deck, so most probably that all uh, the tens will not be placed together, right? So in this case also, whether it can identify the contains all, or whether it can identify the list sublist index or not, that is what we are going to see now. Okay, so once we shuffle that shuffle it, it can't identify that sublist index, because the the sublist here, we don't, it doesn't stay together, so all the elements are not present in the contiguous array. So in this, because of this, it is not able to identify it, so it is giving us a -1 result for this collection dot index sublist. But it contains on all check that if I have 4 tens, it will identify all the 4 since it is present in the same thing. That's why it's saying that okay, I have it properly. Okay, so that's why for that it is showing me true. So that's the difference between the shuffle and if you have deck shuffle, and if not, doesn't do the shuffle the deck. It has a difference here, and it makes difference when you do the sublist index as well. Now there is something called as disjoint function. So given two lists, it will try to check that whether you can it has whether it has common element or not. If it is common element, it will give negative value for this. So for it gives true and false values. So let's say boolean disjoint, and if you do collection dot disjoint deck and tens, and just do system.out.println, and we just print out the value using the disjoint function. That is one thing. Another thing that we can do here is just copy it and try to compare the two different aspects. One is kings and one is tens. So if I do this and let's say disjoint 2, if I just keep it like this, and let's run this code. So disjoint, what it try to do is it compares two list and returns true or false if there is no common element. True if there is no common element. common element in the list. Okay, so this is what we have written here. So first, when we check the deck and given tens, if we do this, it is giving this joint as false because this is a common element, because tens are present in the deck. But when we do for kings and tens, because it's club of list of all the kings and list of all the tens, there is no common element. So in this case, it is giving us true. Okay, so this is another function coming from the collection class. Now, apart from this, we can do something called binary search in this list also, but the condition is it has to be sorted. That's the first condition. Also, if there is a duplicate element, it can't exactly specify which and you call that, and you want to search that duplicate element within the list, it can't exactly specify which element are we talking about. Can't specify the element index properly. Okay, so that is one part of the binary search. So to do that binary search in this case, uh, so what we have to do is, uh, first we sort it. So deck dot sort, sorting algorithm. So we'll sort the deck. Then uh, let's say we have to search certain value, right? So let's say 10 of hearts. So for that, let's create that value. So card dot get numeric card dot suit dot heart and 10. Okay, so we created a numeric card and we try to search this card in the deck. So what we'll do, int found index, and using collection dot binary search deck, from deck tens of heart, this is the heart that we're trying to find, and the sorting algorithm. So binary search, even if you don't sort it, it will have to specify explicit sorting algorithm. It will sort it first and then it will find tens of heart in this particular deck. Okay, so once we do this, and we can print it out the value, found index, that is one way. Another way is, uh, if you don't want to do binary search also, so, or if you so how we can find this, instead of contains also, if you don't want to do that, so you can do deck dot index of and tens of heart. That is one way. Third and the last third one is system dot print deck dot get function found index. Okay, so we have used three function here. One is using binary, this is coming from binary search result. Okay, this is the alternative of binary search of finding an element, and this is also index using the get function. So once after binary search, we can use this get function. So once we try to run this code, okay, so our final output is actually this last three lines. Okay, So the found index in this case is 34 using a binary search. The same thing, we can get the same answer from using index of also, for particularly extracting the index. And once you get the index, you can also extract the element of which you need using the get function. Okay, so this is for finding it. Now let's see whether we can replace certain elements also or not, certain elements or all elements. So how can we do that with respect to this? So let's look at that. uh, so we can use a for this we will take new card, let's say 10 of clubs, and card called ticket numeric card, and card dot suit dot club and 10. Okay, so 10 of clubs we're extracting, and let's say you want to collection dot, you want to replace them. So collection dot replace all in the deck. So you want to replace 10 of clubs, sorry, yeah, 10 of hearts. And then okay, so you want to remove 10 of clubs, 10 of hearts, you replace 10 of hearts with all the 10 of clubs present in the deck, okay, using replace function. So once we do this, we just need card dot print deck. um, so we don't need to print all the stuff, so we can just looking at deck dot sublist, and it's coming from 32 to 36 row because we have sorted it again properly. We did providing the description, since we are removing from the 10 rows only, so we are looking out for that and just printing out the one row. So let's run this part. Okay, so if you can observe here is the clubs was there here at the first position. Now it has been removed, it has been replaced with the heart. So that's how it is happening. To show that one more time, I will just do it, just reverse it. So let's do this. Instead of clubs, I'll replace the hearts in this case, and here 10 rows, same, everything is same. So we're just removing the hearts in this case with the clubs, and let's see how it will work it out. So as you can see that this using the replace all function, earlier we replaced only one value, in this case club to hearts. Now we have two hearts, so we have changes with the club. So that is something we can extract it using replace all function. After also, if you want to use replace all function, you can use it with if condition. So let's say you want to check before replacing, you want to check whether that part exists or not. So let's say replace all, and you say tens of heart, again you're replacing with tens of club. Okay, so if that is the case, you just do system.out.println and say that 10 of heart replaced with tens of clubs. Okay, else just print it out, no tens of heart found in the list. Okay, so once you try to do this, it will say that whether I can replace this or not. As you can see in the current state, you can't replace it, so it should print out this part. Okay, so if I just run this code also, you can't just replace it all the time. So at one time, if it doesn't give, so it will give us a false value, and based on that, we will print out the else statement. And if you want to know that how many duplicate elements are present in this particular list or array. So you can use a frequency word here, frequency function. So what you have to do is system.out.println card collection dot frequency deck. I will pass from where you have to check, and you have to pass the card in this case. So if I just do this using frequency function, it will calculate all the duplicates in this present in this of 10 of clubs. So ideally it should print out me the value 2. So let's see. Okay, so as I have seen that number of 10 of clubs has 2, so that's how it is giving me 2 cards. So frequency will tell me number of duplicate elements. Okay, only few functions are remaining, so let me just quickly look it out. So if I want to know that what is the correct card, say best card and the worst card in the particular deck, I can use min and max function, max and min function. So let me write down the code for this. So println, if I do best card and collection dot max, and in this I have to do deck, I have to do sorting algorithm. Okay, if I do this and I have to do worst card also, and collection dot min. Okay, so what min and max function is doing is it will based on sorting algorithm, the sorting algorithm that we have defined, let's say somewhere up. Let me see where it I have written. Yeah, in this it will look at the rank, because that's the first comparator that we're looking into. So it will look at the rank and will print out the best card and the worst card in this case. Okay, comparison based on rank. So if I run this code, so same thing, it will go for min also. So based on sorting algorithm, it will look out for best and worst card. Okay, so it is giving me best card as the last card, that is spade as 12, and the worst card is 2 of clubs as 0. Okay, because the sorting algorithm first look at the uh, rank followed by suit. So in this case, the highest in suit, highest value is given for spade and the lowest value is given for club. That's why the output in this case, spade has the highest value, uh, obviously followed by rank, and here it's a lowest value of club followed by its rank. Okay, that is one thing. One more last thing that we can do here is it is for rotation, that we can rotate our values. We can rotate our values present in that list, array list or any kind of list, using collection method. So we can do that using rotate and unrotate. Okay, uh, so to do that, uh, basically rotate in this case. uh, so let me write list card, let's say copied new array list, deck dot sublist, and I will take first 13 values from the deck, and In this I will, what I do is collection dot rotate, copied, and distance let's say 2. Okay, and what I will do is just show the between before rotation, after rotation. So unrotated deck dot sublist 0 to 13 and system dot out dot println rotated um, -2, you can print it out. Copied. Okay, so this is the last function that we are looking for today. So if we just do this, okay, so this is the original deck that we are having, the first 13 letters. Okay, so it has 2 of clubs till 5 club of 3. Now when we are trying to rotate it, what is happening is this last 2 cards are actually coming from from last to the front 2. So you can see that the rotation is happening. Since we are do 2 distance in this case, I should not write 2 -2 here. So what is in the last elements will come at the front and it will replace one by one till end. Okay, so if you have to do something else, let's say if I do -3 in this case instead of 2, or -2 in this case better, if I just run this code, so the last element comes at the first. That's how the rotation is happening. But if we do that in a negative way, okay, I think in negative way it's not happening properly. Yeah, I think distance has to be positive in this case. No, 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 no. I think I was wrong. Sorry. Yeah, so in negative way, the first 2 elements will go at the back. Okay, so if you do negative in distance, the first 2 elements from the unrotated part will go to the back at the rotated. Okay, so these are the few functions in the particular uh, collection thing that we have seen. I think 14 to 15 functions already. So the first functions, 4 functions are all if you want to copy from one element from one list to another list or any other kind of data, you can use add all n copies, copies, and copy of. You can shuffle the data using shuffle function. uh, you can sort the data, you can reverse the data. If you want to extract sublist, you can extract using sublist, but you should know the index of that particular sublist. Now if you know the that is one thing. If you have the sublist and you want to extract it from the particular major list, so you can use index of sublist function as well. And you can use contains all function also to extract, to check that whether the particular sublist is present or not, followed by disjoint. These are the disjoint will check that it compares the two lists, and if there is no common element, it will present true value. Then you can use sorting function. Sorting function you can do is using binary sort, or sorry, if you want to find an element, you can do binary search in this case. So binary search you can uh, when you're doing binary search, you have to pass the original deck, the element which you want to find, and the sorting algorithm through using which the deck has been sorted. Okay, and if you don't want to use binary search, you can use index of element as well. And using get function, you can extract the element from that particular list as well. Then followed by, we have seen replace all function in that particular list. Using we can replace the certain values. We should know, using frequency we can know that number of duplicate elements present in that list. Followed by, we can extract the min and max value of that particular element from the list. Given that, we should tell that how they should compare the elements in the list. That, and the last we have look at the rotate function. Okay, so I think we have covered quite a lot in this today's session with respect to the number of functions that we have seen, and all these function will be used for you during the manipulation part of your list or any object of classes that you're trying to create it on. Okay, yeah, so that's the I think that is the end from my side. Let me check if you have any questions in the chat box. Is Java language is good for DSA in lead code? uh, so basically, if you're looking for Java as a it is good. You can write or you can solve all the questions with respect to it. But when it comes to speed, that how much time it is taking. So if you have very big code and big data, I think you should try to use much faster language like C and C++. But if you want to learn Java as a DSA, it is pretty good, but it is very syntax extensive. As you can see, multiple function we have written, and this very syntax extensive because of the how it has been processed here. Collection dot frequency, collection dot max, it is quite heavy words in this case. So I hope that might give you an idea with respect to it. Any other question? Because session is over from my side. If you have any question, please let me know. Okay, so in that case, I will end the session today. Uh, so if you have any question, please let me know that. I will upload this uh, video soon after ending this session. So thank you everyone for joining this meeting.